Section 8.1, Radical Expressions and Functions. So this is a representation of a radical. So the symbol is considered the radical. What's underneath the radical is called the radicand. And there should be a number shown there. If not, it's an index of a 2. But this is called the index. So again, if that index is not shown, it's going to be a 2. So it says, number 1, find all square roots of 64. When you want to find all square roots, you got to be careful. It's not just 8. So the square root of 64 is actually with a plus or minus. So you get a plus or minus 8. Why plus or minus 8? Because of the fact that 8 times 8 is 64, and negative 8 times negative 8 is also positive 64. So when they say find all square roots of 81, make sure you're putting the plus or minus out in front. And the square root of 81 is 9. Again, right now the index is a 2. It's not being shown, so it's considered a square root. And you have to put your plus or minus in front of the square root. And so you get plus or minus 9, because the square root of 81 is 9, because 9 times 9 is 81. And negative 9 times negative 9 is also positive 81. So without a calculator, I want you to be able to do these square roots. Or cubed roots or fourth roots, whatever the index is. What I always tell my students to do is make sure you highlight any index that's bigger than a 2. Because a lot of students forget about the index and they all just think everything is a square root, and it's not. So make sure you highlight the index. So the square root of 0 is 0, but without a calculator, make sure you're doing these. And the reason why it's 0 is because 0 times 0 is 0. On number 2, negative square root of 4 would be negative 2. Now I'm not putting plus or minus on any of these because the square root is already written. If the square root is already written in there, that tells you which answer they want. Since the negative is on the outside, they want the negative answer. So it would be negative 2. Square root of 1 is 1. Again, why? Because 1 times 1 is 1. Now what's on number 4, what's a cubed root of 1? Well, that means I have to multiply some number 3 times and get 1. So again, the answer is 1 because 1 times 1 times 1 is 1. Now what's the cubed root of 8? What number can you multiply 3 times and get 8? Well, it's 2 because 2 times 2 is 4, times 2 again is 8. You need to do these without a calculator so you understand what's happening later on. The fourth root of 0 is 0 because 0 times 0 times 0 times 0 is 0. Fourth root of 1 is 1. Again, because 1 times 1 times 1 times 1 is 1. Now what's the fourth root of 16? Well, again, what number can you multiply 4 times and get 16? Make sure you start small. And the answer would be 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. Now what number can you multiply twice and get a negative? You can't. Since the index is a 2, there's nothing, not a real number, that you can multiply twice and get a negative. So in 8.1, you're going to say not a real number, because again, you can't multiply a number twice and get a negative. Every time you multiply a number twice, you get a positive. However, in the last section, we learned something about imaginary numbers. So right now, you're going to say not a real number. But once we learn imaginaries, don't write this answer. Talk about imaginary numbers, which is coming up. Now, is this not a real number? Nope, we can do this. Why? Because you're just wanting to multiply a number 3 times and get a negative. So it'd be negative 2, because negative 2 times negative 2 is positive 4, but times negative 2 is negative 8. So when is it not a real number, and when are you allowed to be able to do so? Well, if the radicand, remember the radicand is the thing under the radical, if the radicand is negative, okay, if the radicand is negative and the index is even, so 2, 4, 6, 8, there is no real root. So if it's negative and your index, again, if it's negative, the radicand's negative and the index is even, there's no real root. But if the radicand again is still negative, however, the index is odd, like this example, then there is a real root because you can multiply a number an odd number of times and still get a negative. So we're not just going to have numbers under the radical, we're also going to have variables. So if I had the square root of r to the 8th, what does that really mean? Well, that means 8 r's are being multiplied. So 1, 2, 3, 4, 5, 6, 7, 8. Now we're not going to do this for every problem, but I want you to see what's actually happening. Because the index is a 2, I'm going to circle pairs. And all the pairs get taken out. So if you circle pairs of 2 r's, because again the index is a 2, we see we have 1, 2, 3, 4 pairs. So r to the 4th will be our answer without the radical. We took out a pair of r's, another pair of r's, another pair of r's, and another pair of r's, so we end up with r to the 4th. So do you see a shortcut? We can take our power 8 divided by our index 2, and 8 divided by 2 is 4. So really the shortcut is just to take your power divided by your index, and that's how many come out. Now, what happens if they don't come out evenly? We'll have to talk. So when we have variables under the radical, all you have to do is divide the power by the index. This is your power 8, and your index was a 2. So we're going to evaluate each root. Again, that's just evaluating the radical. Assume the variables represent non-negative values, so we're not going to have to worry about putting in any absolute values or any imaginaries under, or any negatives underneath the square roots. And so we're going to assume that the variables represent non-negative values. Everything's going to be positive or 0. So on number 1, we have the square root of 81, r to the 6. Can we multiply a number twice and get 81? Yes. 9 times 9. And then we take 6 divided by 2, and 6 divided by 2 is 3, so we end up with 9r to the 3rd. Again, try and know all your square roots and cube roots up to, a good amount, so you're not using your calculator. What's the square root of 121? 11, because 11 times 11 is 121. We take power 8 divided by index 2. 8 divided by 2 is 4. 10 divided by 2 is 5. So we end up with 11, x to the 4th, y to the 5th. Number 3, the cubed root. Here we go. Highlight it. Make sure you highlight anything that's not a square root, because there's a lot more thinking involved. So now I need to multiply number 3 times and get 64. Well, 2 times 2 is 4 times 2 is 8. That didn't work. 3 times 3 is 9 times 3 is 27. That didn't work. 4 times 4 is 16, times 4 again is 64. So we know the cubed root of 64 is 4. Take power divided by index, so 12 divided by 3 is 4. 9 divided by 3 is 3. So we end up with 4u to the 4th, t cubed. So now on number 4 we have the 4th root. The 4th root. Is there a number I can multiply 4 times and get 16? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 is going to come out. Power divided by index. 24 divided by 4 is 6, so a to the 6th. And 8 divided by 4 is 2, so we end up with b squared. So 2a to the 6th, b squared. If we have a fraction underneath the radical, we still do the same thing. We're going to simplify each one. The square root of 25 is 5. And 8 divided by the index of 2, we get x to the 4th. Square root of 49 is 7, and 2 divided by 2 is 1, so we get y to the 1st. You don't need to write the 1. I'm just showing you that you still have to have a y there because y does have a power of 1. Are we allowed to have a negative under the radical on number 6? Yes. Why? Because the index is a cubed root, so we are allowed to have a negative. So what can I multiply 3 times and get a negative 27? Would be negative 3, because negative 3 times negative 3 times negative 3 is negative 27. Power divided by index, 15 divided by 15 divided by 3 is 5. And 3 divided by 3 is 1. I'm not going to put the 1 this time because you understood to be there. So we have a negative 3, x to the 5th, y to the 1st. So the last part of this is find the indicated function value. So we're going to want to be able to find f of 0. And we've done function notation before. That just means x is going to be a 0. So 3 times 0 plus 9. which is going to be the square root of, well, 3 times 0 is 0, plus 9. So we get the square root of 9, and the square root of 9 is 3. Again, we do not put plus or minus because the square root was already there, so we know that our answer is just going to be f of 0 equaling 3. We also need to find f of 3. So f of 3, we're going to plug in x being 3. So we get 3 times 3 plus 9. 3 times 3 is 9, plus 9. So we get 9 plus 9, which is the square root of 18. And this is what's going to be happening into our next few problems. What do we do with that? There's not a nice square root of 18, but there might be something that can come out. So put a dot, 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 because we're going to learn what we do with that in the next couple of sections.